Consider the function f of x equals 1 minus x if x is less than 2, and 1 if x is greater than or equal to 2. So that's a piecewise function that looks like this, and we see the 1 minus x portion of the graph here, and an open circle down here, and then the 1 part of the graph here, and a closed circle right there. And so as we approach 2 from the left, the value of the function gets closer and closer to negative 1. So as we approach 2 from the left, so here's 2 on the x-axis, and if we imagine on the x-axis moving the x-coordinate closer and closer to 2, the y-coordinate as we travel down the graph here, as we get closer and closer to 2, that approaches negative 1. Now, as we approach 2 from the right, we saw that the graph approaches 1. The value of the function approaches 1. So on the x-axis here, as we get closer and closer to 2 from the right, on the actual function, we get closer and closer to 1. In fact, we just stay at 1 here. So the limit of f of x as x approaches 2 does not exist, and that's because the limit as we approach from the left does not equal the limit as we approach from the right. But what if we only cared about the limits coming from one direction? What if we didn't want to look at the total limit, but we just want to look at the limit as we approach from the left, or the limit as we approach from the right? Well, there is a way of doing that, and that's using one-sided limits. So from the left, we can write that as the limit as x approaches 2, and then we have a little minus sign right here. So notice this is not negative 2, this is positive 2, and then a little superscript minus sign right here. And that means that we're approaching 2 from the left. And so the limit as x approaches 2 from the left of this function we saw was negative 1. And then from the right, we see that the limit as x approaches 2 with a little plus sign here, we have a little superscript plus sign. This means as x approaches 2 from the right of the function was positive 1. In order for a two-sided limit to exist, that's the kind that you normally deal with, the limit from the left must exist, and the limit from the right must exist, and the limit from the left must equal the limit from the right. If these three conditions hold, then the two-sided limit exists. So in other words, the limit as x approaches a of f of x equals L, if and only if the limit as x approaches a from the left of f of x equals L, and that also equals the limit as x approaches a from the right of f of x. So let's look at the function f of x equal 2, x plus 2 when x is less than negative 1, and x squared when x is greater than negative 1. So we have a graph that looks like this, and here is the x plus 2 portion of the graph, and then we have an open circle here because we have nothing or equal to here. We just have the less than and greater than symbols, and then we have this parabola right here. That's the x squared part. And so if we look at the limit as x approaches negative 1 of f of x, we can first ask, well, what about the limit from the left and the limit from the right? What are those? So from the left, the limit as x approaches negative 1 from the left of f of x is positive 1. So we can imagine on the x-axis from the left getting closer and closer and closer to negative 1. What happens to the graph? Well, we would follow the graph up here. As we get closer and closer to negative 1, we see that it approaches 1. From the right, the limit as x approaches negative 1 from the right of f of x is also positive 1. So now we're going in this direction here. We're approaching negative 1 along the x-axis. And what's the graph doing? Well, it's going down here and then up here, and we're getting closer and closer and closer to 1 on the y-axis here. So since we have the two limits existing and they are equal, we can say that the limit as x approaches negative 1 of f of x equals 1. Let's look at another example. How about f of x equal to 2 minus x squared if x is less than or equal to 2, and 3 minus x if x is greater than 2. So it's another piecewise function. We have a parabola for the first part and then a line for the second part. So here is the 2 minus x squared part. Notice a closed circle here because we have if x is less than or equal to 2. And then this part right here is the line with an open circle because x is greater than 2. And again, let's ask, what's the limit as x approaches 2 of f of x? So in this case, let's look at the left and right hand limits. I think you can probably guess they're not going to be the same in this case, but let's just check. So from the left, we see that the limit as x approaches positive 2 from the left of f of x is negative 2. So again, imagine going along the x-axis until we get close to 2, and on the graph we would be going up and then back down. On the y-axis, that corresponds to going up on the y-axis and then back down, and we get closer and closer and closer to negative 2. From the right, the limit as x approaches 2 from the right of f of x is 1. So on the x-axis, we move closer and closer to 2 from the right. What does that do with the graph? Well, on the graph, we get closer and closer to 1. If we're looking at the y-axis, we're essentially starting down here and moving up the y-axis and getting closer and closer to 1. Since these two limits exist and are not equal, we would say that the limit as x approaches 2 of f of x does not exist.